Now that we've been through the process of finding the measures of angles in circles and segments in circles, our goal is to now actually talk about the measures of circles themselves. So we only have a couple of definitions to talk about and then a couple of processes to roll through, but it'll be pretty quick. So those two definitions that we need to talk about would be the circumference and the arc length of a circle. So what the circumference is just the distance around a circle. In other words, it's the perimeter. So if I have a circle, itself, here's a pretty good circle. When I talk about the circumference, what I'm talking about is actually measuring around the length of this entire thing. So one trip around the circle, what is the measure of it? Now, we've already kind of talked about this when we've talked about the measure of arcs, when we've talked about the degree measure of an arc. But now I'm actually going to be talking about the length. So this will be a measurement in some type of linear unit, so inches or feet or yards or centimeters or miles, whatever it is. I can measure a circle's circumference, the distance around it, actually in a linear unit. And so then what an arc length is just a portion of that circumference. So let's say I want to have 1/3 of the entire circle. I could do that. And again, this is going to be a linear measurement. It's not in degrees. It's actually talking about how far, like if you were traveling around the circle, if you were walking around the circle, how far would you actually go? So these are probably things that you've seen before, but we're going to introduce them as if they're new. And so what that is that the circumference of a circle, its measure will actually be equal to pi times the diameter. So pi, what this number is, if you haven't seen it before, which I'm sure you have, is an irrational number. It starts off 3.14159, and it'll keep going for a long time. In fact, a very, very long time. In fact, it'll go on infinitely long. It is irrational. It never stops and never repeats. And so what pi is pi was actually something that we have generated here, where if you take any circle, whatsoever, and you take the circumference of it and you divide it by the diameter of that circle, so in other words, take the ratio of those two things, it'll always be equal to pi. The circumference will always be pi times the length of whatever the diameter is. So if I have a circle that has a diameter of 1 inch, then the circumference about it would be pi times 1 inch, so about 3.14 inches. If I have a circle with a diameter of 2 inches, then the circumference will just be pi times that, so 6.28, and then so on and so forth. And so pi is this number that we have created, that, discovered, created, however you want to think about it, which is just the ratio of these two values in any circle whatsoever. And so another way of thinking about this as well is that, if I were to take the diameter, so maybe draw this in a different color, but if I were to take the diameter here of a circle, here's my diameter, and I were to, pick this up and then place it along the circle itself, I would take 1, and then 2, and then 3, and then a little bit more of these, take about 3.14 of them to actually go around the entire circle. That's what pi is. It's just this relationship between the circumference and diameter of any circle. So anyway, we can rewrite this equation now to just say that, well, if I know one or the other, I can tell you that my circumference is just equal to the pi times diameter. Another way of writing the same thing, of course, is, well, what's another way of thinking about the diameter? It is just 2 times the radius. So another very common formula you'll see is that the circumference will be equal to pi times 2 times the radius, which will be more commonly written as the circumference is equal to 2 times pi times r. So these are 2 ones you'll see most commonly written in this form, but it's just this relationship between the radius and then with the circumference. And so again, the circumference is just a linear measurement here in terms of feet or inches or centimeters or yards or whatever it's going to be. So then the arc length then is just a portion of that. So if I were to have a circle and my entire circle's circumference was 3 feet, let's say, then I could have an arc that is just 1 foot of that. So it's just a portion of it. So the way that we generally talk about these arcs is, let me draw another circle. If I draw another circle here, that's going to be a great circle. There we go. I can talk about just a portion of it if I want to. So in this case, let's say my center is right about here. I want to just talk about this arc here and actually measure that. And so just like we've talked about before, I can refer to this as arc AB. However, I'm not referring to the measure of arc AB. That would be referring to the degree measure that makes it. This will be actually called the length of arc AB. That's how I'll talk about length and not the degree measure of it. And so I can talk about this measure, and the way that I find it, sorry, the length, I should really say the length. The way that I find it is I talk about, well, see now the confusing part, the measure of this angle in here. Because there's a relationship here. So let's say I know what the circumference of this entire thing is. Well, the arc here, the length of the arc will just be a fraction of it. So here's how we can think about this. So let's say I've got this, we'll name this circle, we'll call it O. So if I have the circumference of circle O, and actually let me write down the bottom, it will be proportional to the length of this arc AB. So the length of arc AB relative to the circumference of circle O, it'll be proportional to whatever the degree measure is. So in this case, the measure of, I can say the measure of arc AB, or I could have said the measure of this AOB angle here, over 360 degrees. So let's just say, real quick example here, let's say I told you this angle right here was 60 degrees, and let's say I told you the circumference was, 10 feet, why not? Then to find the length of arc AB, well, it would just be, this fit into this proportion here, the length of arc AB, so length of arc AB will be proportional to, we said 10 feet, in the same way that the measure of that arc, which was 60 degrees, is the 360. So in other words, it's going to be 1/6 of the entire thing. 1/6 of the entire thing. So this length of arc AB, this right here, would be 1/6 of 10, which is about, 5/3 or something like that. 5/3 feet.
Someone's at the front door.
You gotta be kidding me.